Hi there, I'm Alberto Gutierrez, and this is the Practical Actuary channel. This is part 2 of the series RAG-based Knowledge AI Agent, and in this video, I'll be walking you through on how to build an IFRS 17 Knowledge AI Agent. I do recommend that you watch part 1, which I give an overview of the concepts, and you can find the link to the video in the description below. So let us dive in. Okay, before we start coding, we need to plan our system, how we're going to build our application. Okay, so firstly, we need a set of documents. And these are IFRS 17 documents, which will contain, whatever information that is related to IFRS 17. And I'll just call them IFRS 17 docs. And these docs will then go through an embedding model, a text embedding model, which will then be stored in a vector database. Now, say we have a user. So that's the user there. And this user has a query. This query will go through an LLM, and we'll just call it an LLM1. And this LLM1 could either respond directly to the query, so back to the user. So this is the user here. Could either respond directly to the user, or could, call a function, a tool, where this tool includes a list of functions, right? But in this case, we'll only have one function, and that function is get IFRS 17 info. And this function only has one parameter, which is a string, and the name of that parameter is a query. And this function will then be used to pass the query, and embed that query, and then use a similarity search function, which will then pull the relevant stored IFRS 17 docs, and that will then go through an LLM here, so we call that LLM2, which there will be some prompt engineering that takes the context into account and responds to the user. And that there is a RAG-based response. So this is essentially the system that we can build. And now we just need to think about what we're going to use, what models we're going to use. So from a text embedding perspective, we can use something called nomic embed. So there's a nomic embed model. So for those of you who don't know, the nomic embed model, there is let's go to it. So there's a paper here which was drafted in 2025. And it's essentially a technical report, right, that describes the training of nomic and bed text, the first fully reproducible open source, open weights, text embedding model that outperforms both OpenAI, the ARA002 and the text embedding 3 small, on both the short-term and the long-term context benchmarks. So yeah, this is the text embedding model that we are going to use. Okay, and the vector database that we are going to use is Chroma. Okay, and Chroma is essentially an open source AI application database. And it makes it easy to build LLM apps, by making knowledge, facts, and skills pluggable for LLMs. So this is the vector database that we are going to use, and Chroma gives, as mentioned here, Chroma gives you everything that you need for retrieval. So it can store embeddings and their metadata. You can do a vector search, you can do a full text search. It also stores the document. There's some metadata filtering when you're doing some queries. And it also has a multi-model retrieval. So this is what we're going to use for storing our documents and doing some vector search on those documents. Okay, and for LLM1, we can use a simple small LLM. So in this case, we're going to use a gamma model. And this gamma model is a 1 billion parameter model. So I think it's a gamma 3 that we're going to use, or gamma 3, that model that we're going to use. And then for LLM2, which is essentially then taking the context and providing a response to the user, here we're going to use a Phi 4 mini instruct model. Okay, so those are the models that we use. And these models can be found in Hugging Face. So this is Phi 4 mini instruct. So as you can see, it's about 3.84 billion parameters. And this has been built and trained by Microsoft. And the Gamma 3 1 billion parameter model, this has been trained by Google. So these are the two LLM models that we're going to be using. Now, we have our system, we have our models, we have our database, but now we need an interface, right? In which the user will make a query and sort of like a chatbot interface. So that chatbot interface, we are going to use an application called Gradual. And Gradual has been developed by the Hugging Face team, which is a nice interface to build quick LLM sort of applications. But now we need something to orchestrate sort of the system. And what we're going to use here is essentially something called LangGraph. And this is by the LangChain developers. So yeah, we're going to be using the LangGraph to sort of orchestrate sort of the query and using a tool and some tool call and function sort of invoking. So that's what we're going to use. Now we have the system, but now we need to understand what can go wrong with the system, right? in what scenarios can the system fail? So if we start with the documents, right? The system can fail if our documents contain outdated information, contains irrelevant information, factually incorrect information. So we sort of then need to make sure that the documents that we're feeding into the vector database is updated. And if you're implementing sort of a RAG-based LLM system in your organization, I suppose you just need to make sure that there's a process in terms of reviewing the documents, approving those documents, and providing some sign-off, before they're then processed into a vector database. So that process just needs to ensure that all the documents that are in the vector database are relevant and up to date. Okay, then the next thing is supposed to ensure that our text embedding model is a very good text embedding model. There are many text embedding models, but they may not necessarily be appropriate for the specific knowledge task, knowledge intensive task. And so you just need to pick the right text embedding model. So in this case, I chose Nomic Embed as one of the state-of-the-art text embedding models. Of course, there are other text embedding models that might be more accurate in specific domains, but this is the text embedding model that I have here. And then from a similarity search perspective, you can have a different measure, right? So you can have like an L2 norm search. You can have a cosine similarity search. You can have an inner product search. So there are different types of distance functions that you can use in order to retrieve the relevant documents. I'll probably say that you probably need to pick the appropriate distance functions that is the same as what was used to train the text embedding model. Okay, now from a user perspective, right, the query that the user makes, an LLM has to choose whether to respond directly to the user or to use a tool, right? Now, one scenario in which this thing can fail is where a user asks a query which requires the LLM to call the IFRS 17 tool, and it does not call. It does not call the tool. Which means then by definition of the system is that it's going to respond directly to the query and answer an IFRS 17 related query, which will essentially then use the information retrieved from its own internal parameterized memory and not necessarily from the retrieved documents. And that in itself, can be incorrect, can be inadequate. And I do cover this piece in part 1. And that can be exacerbated by the fact that I'm using a very small model. It's a 1 billion parameter model. So if it does not call the tool and responds directly to the user, that response might be of a very low quality, low accuracy. The second scenario in which the system can fail is that, let's just say it correctly identifies that the tool needs to be called. And the way it does that is that it returns a function name or the tool name, as well as the function arguments. right? Or the parameters. And as it returns this function name with the arguments, those are then passed and the function is then called, right? And the function is invoked. Now the LLM can actually get the function name wrong, right? So let's just say there are multiple tools and it can pick the wrong tool. That's one way of getting it wrong. Or let's just say that there is only one tool, but it actually hallucinates a different name. So as an example, instead of saying get IFRS 17 info, it might say get IFRS 17 description, get IFRS 17 definition, which is not really a valid function name or tool name. So there's a possibility of the LLM actually hallucinating the names. And likewise for the arguments, it can get the argument wrong. It can get the argument type wrong. So a way of essentially mitigating this could be using a very good LLM that is shown to do very well in terms of tool calling. There are LLMs that are fine-tuned for tool calling. So yeah, that's essentially one way of mitigating failures in this side. But another way in which the system can fail is the function argument. And this is where the LLM actually generates an appropriate query, which will then be used to do some similarity search to retrieve the relevant documents. And it might be that the LLM might generate an inadequate query statement, right? So an example could be a user asks, what is the definition of an insured event under IFRS 17? But then the LLM basically then generates an argument string that says what is the definition of IFRS 17. Now those are two completely different questions, but that's a possibility, right, of LLM generating that query. And as a result, it's going to pull the relevant sections, which speaks to a definition of IFRS 17 as opposed to a definition of an insured event or an insurance event. So yeah, I think it's just ensuring that the LLM, is best suited for this type. Obviously, the bigger the LLM, the better. The more fine-tuned the LLM, the better. So that's one way of mitigating it. But just assume that everything is right. Everything is accurate. So it calls the tool, the function name is right, the argument query string is right. It retrieves the appropriate documents, the relevant documents. Now we then need to sort of structure, or the LLM needs to then respond to the query given that as context. Now the prompt engineering, which is an art, right, needs to be adequate enough. It needs to be structured appropriately. If the prompt engineering is not of good quality, then the response might also not be of good quality. The LLM also may not necessarily be able to reason through the context and understand how that relates to the user query in order to then provide the appropriate response. And maybe a way of mitigating that is through using an LLM that has been trained to reason through queries and context and provide that response. Or it could be just it can be mitigated through just like very, very good prompt engineering, and as well as using bigger LLMs with bigger size parameters. So yeah, this is our system. We understand kind of like the graph of our system. We understand the LLMs that we're using, the tools that we're using. We know where the systems can fail and what we can do to mitigate. But I have hardware constraints. I can't afford to host a very large model. I suppose I can spend some money in terms of then using closed source models such as OpenAI, but I'm just gonna use the open source models and host it in my local machine. Okay, so this is the system. Now it's time to implement the system, and we're gonna do this in Python. Okay. Firstly, we need to host our LLMs, and the application that I'm using is LM Studio. So LM Studio, I suppose it's an open source application which you can then download LLM models as well as text embedding models, and then host them. All right. And the endpoints are essentially the same as OpenAI. So it's an OpenAI API. So at the moment, I've downloaded, as I mentioned, the Gamma 3 1 billion parameter model, as well as the 5.4 linear struct model. So I'm going to load those two models. So we're loading the Gamma 3 model. And what I do want to make sure is that it can take up to 8,000 tokens in terms of the context length. So let's just reload that. In the meantime, I'll also bring in the 5.4 mini struct model, and likewise that will have let's just have slightly more, we'll just say 12,000 in terms of our context length. Okay, and I'll also include a text embedding model. So in this case, it's the nomic embed text model, and it's the version 1.5. And yeah, that can take up to 2,000 tokens as a context length. And all of this is loaded into my GPU, and they're ready to be served. And these are the endpoints. And it's served through my local host on port 1, 2, 3, 4. And yeah, it's ready to be used. Okay, so now we're here in our Python application. But first, the requirements, which specifies the libraries that we're going to use. So as I've mentioned before, I'm going to use the Gradio library, which will be used to build our chatbot interface. We're going to be using the LangChain libraries, specifically the LangGraph library, which is going to be used to construct our RAG application. ChromaDB will be used for our vector database, and PyPDF is just a library to parse our PDFs. Now, the IFRS 17 documents that we're going to use is just going to be two. One will be one which has been drafted by EY, which is titled Applying IFRS 17, a closer look at the new insurance contract standard. This was drafted in June 2021. And then the others is the actual IFRS 17 insurance contract principles that we're going to be using. Okay, so these are the two documents. Okay, so let us go into our Python script. Yeah, so I mean, there are two folders here. One is the documents folder where we store our IFRS documents. The other is a DB folder where we store our vector database. So we have a function here that creates vector database, which is based on arguments. So that's the embedding. So this is the embedding function, or the embedding, the embedding function. And this will just be the name of the collection, right? So the name of the set of vectors. So in this case, it can be like a IFRS 17 collection. So what this function will do will essentially then look through all the documents in the document folder, and then store them into a list in a variable called documents. And we then create a vector database using Chroma's .from documents definition there, which takes in the collection name, the documents that we've just loaded, the embedding function, and we determine whether there is a persistent directory. In this case, it's the DB folder. And yeah, this is a simple, Chroma does have a very nice function, which is as simple as that in terms of creating a vector database. Now, embedding function, we are going to use the OpenAI embeddings. And OpenAI embeddings we take from the LangChain _OpenAI library .embeddings. And in there, we specify the base URL. So remember, I am hosting 3 models, 3 endpoints in my local machine using LM Studio. And the name of the model is a text embedding dynamic embed. So there isn't any 8-bit key that's required. I suppose it's just an LM Studio bug, but to remove that bug, we just specify the check embedding context length to be equal to false. Okay, so yeah, that's my embedding function. And this here would be essentially the function to create it if it doesn't exist. So I pass that embedding function, and the name of the collection is IFRS 17 collection. But if it does exist, and all I want to do is just load that database, vector store, then I can just use the Chroma function. My embedding function will be embeddings. That is my collection name, and we know where that database is stored. So it's basically loading the Chroma database. And then for my LLM, so I'll use 2 LLMs. One I'll just call LLM, which is using the 5-4 mini struct model, using the OpenAI function. And I'll create another LLM, and I'll just call it SLM, which stands for small language model. And this will really use the Gamma 3 model, which is a 1 billion parameter model. Okay, then I define my tool, which is, the name is get IFRS 17 info. So that's the name of the tool, which has a string argument by the name of query. And that query is basically a generated query to search for relevant IFRS 17 documents based on the user's query, right? And the response type here would be content and artifact. And what that means is it just, returns 2 values. So one is a content, and the artifact is basically the retrieved documents. Okay, so as you can see in here, that vector database of Chroma has a function called similarity search, and I just feed in that query string, and it returns the top 5 relevant documents. So the number of results that it returns is 5. And in there, I create a serialized, serialized value, which is essentially then just a long string, I suppose, of source and content for all the retrieved documents. So in this case, it's going to be 5 instances of both source and contents, and I return that with my retrieved documents. So yeah, that's my tool, which then interacts with the Chroma vector database. Now, I need to create my first LLM. So LLM 1. So if you remember, LLM 1 is essentially this component here. So that's what I need to create now. Now I call that query or respond. Maybe I should have said respond or tool, but in here, essentially then I bring that tool function into a list of tools. So in this case, this tools only has one tool, and I bind it to the SLM, which is my Gamma 3 model. And this then becomes my LLM with tools. And in here, I basically say there must be a maximum of 5 retries. So I mentioned earlier that there are potential scenarios where this thing can fail. So because I'm using a very small model, this small model can return an incorrect function name, can return an incorrect function argument. So this is basically my way of mitigating against that. So some sort of exception handling. So in here, I basically extract the messages. I'm, sort of creating my own tool list with the description. And in here, for every try, I invoke the prompt, which is the message. And that will return a tool, right? A tool with the function name and function arguments. And this is just me doing some validation on it. And if the validation hasn't passed, I basically then try again, right? Where this time there is a new message that I am appending to the prompt, where it says that the tool is not found in the tool list, use one of the following, which is what I create over there. Okay, so that is my LLM 1. And now I need to move on to the tools. So this step here. Okay, so creating a tools is as easy as that, right? There's nothing, I suppose the tool node here, LangGraph, the pre-built, provides a nice class there, which you can instantiate by providing a list of tools. So it's as simple as that. Okay, so now we need to build our LLM 2. So this is the LLM 2 over here. And yeah, so this is the name of the function here is just called generate, which will generate a response using the retrieved content. So in this function, we essentially then just strip out all the tool calling messages from the LLM so that it only contains the interaction, right? So the human message as well as the system message or the AI message, and removes all the tool messages. And in here, I'm doing my prompt engineering. So I'm saying that you're an IFRS 17 expert, blah, 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 blah. Use the current context. This is the query. Then, we need to provide an answer. And that will invoke the prompt and then return a response. Cool. Now I use Graph Builder to basically build my RAG application, right? So in this Graph Builder, I instantiate a state graph with the messages state. That means that it's going to keep a history of my messages. And I add nodes. So I add my LLM1, I add my tools, I add my LLM2. And the entry point is essentially my LLM1. So that's where I start. And then there are conditional edges, right? Where essentially then between my LLM1 and tools. So it will basically determine whether if LLM1 then invokes a tool, says that the tool needs to be called, this is that function that enables that. Okay, then I add an edge. There are two edges, which is tools and generate, and I compile that graph. So this here essentially then implements this system here that I drew up earlier on. Okay, and then now it's time to build my chatbot interface using Gradio. Okay, so I won't go into too much details, but essentially here I'm creating 3 chatbots, right? The first chatbot is a small basic chatbot using Gamma 3, 1 billion parameter. Then the second one is a basic chatbot using the 5.4 mini-struct model, and then the other one is the RAG-based chatbot. So the reason why is we're gonna compare the quality of the response from 3 different chatbots. One is a simple Gamma 3, it's not a RAG-based. Second is a 5.4, it's not a RAG-based, it's 1 billion parameter, then 4 billion parameter, and then sort of my RAG system. And so this is just all the code that I used using the Gradio library to then build that interface, and then I launch that demo. Cool. So I'm going to run this, and this will then essentially serve this demo, this Gradio application into a web browser. And let's finally test our chatbot system. All right, so we have our Gradio application. So as you can see, there are 3 chatbots here. So we've got the one with the small LLM, Gamma 3, 1 billion parameter model. The second is the 5.4 model, which is a 4 billion parameter model. And then we have our RAG application. So we're just gonna test with them. I simply send hi, so the first one does work. The second does work, and then the third one definitely works. Okay, so now we're going to ask an IFRS 17 question. So what is the definition of an insurance contract under IFRS 17? So this is the question that we're going to ask everywhere, and let's see what the response is. Okay, so so I'm loving music. Wait for the LLM to respond. I don't have like a huge data center full of GPUs for this to respond quickly. I do have single GPU, which I'm loading all models into the single GPU. Also not string tokens, I'm just okay. So it's a very detailed response from Gamma 3. And it's very comprehensive. So there's a core concept here as insurance-related transactions. So IFRS 17 fundamentally shifts how insurance contracts are treated. Instead of classifying them as insurance service, it views them as insurance-related transactions. This is a crucial departure from previous accounting standards. The definition here is considered insurance primarily based on expectation of future financial gain from a risk. It doesn't necessarily mean the insurer guarantees expected benefit. Okay. And then there's something about probability of loss test. Okay. Quite a detail, but I don't think that's the correct definition. And as you can see, the URLs don't actually work. Yeah, the URLs don't actually work. So it's probably hallucinating these URLs, or potentially maybe they did exist in the point in time. So at the time when this was trained. Yeah, so that's the first one. Okay, now for the second one. Okay, so it's also a detailed response. An insurance contract as defined by the International Financial Reporting Standard 17. Insurance contracts refers to a contractual agreement between two parties. One party being insured and seeking protection against certain risks through transfer mechanisms such as premium payments, while the other is providing that coverage in exchange for consideration. Yeah, so then it goes in and says, in essence, the contract meets IFRS 17's definition of insurance if it involves the transfer and retention over time in exchange for consideration, so one-time premium payment at inception, periodic payments. Okay, so this is quite detailed. But let's just see our RAG system. All right, okay, so it's nice and concise. And it says here the definition of an insurance contract under IFRS 17 is a contractual arrangement where one party, the insurer, accepts significant insurance risk from another party, the policyholder. The agreement involves compensating the policyholder if there occurs within the coverage period and in accordance with its terms and conditions as specified by the law for each insured event. This definition determines which contracts are covered under IFRS 17. And it provides a source, so Corner Pirati, which I suppose that's the EY document called Applying IFRS 17, a closer look at new insurance contracts. So then it provides even the page number. So yeah, let's go look at the page number actually. Effective definitions included within Appendix A of the standard are likewise included here. An insurance contract is there. Yeah. And I just want to see where. Surely one must be over here. Okay, so I suppose it pulled page 13, but page 13 had a list of things where a list of items for which there would be definitions. But this is a definition, right? A contract under which one party accepts significant insurance risk from another party by agreeing to compensate the policyholder if a specified uncertain future event adversely affects the policy holder. Yeah, so this is the definition, right, of an insurance contract under IFRS 17. And that's what it says here, right? This section here and this section here as well. So I think this is quite a good response from the RAG application. Okay, now let's try a different question, a different query, which requires some reasoning through this query. And here we're gonna say, so we have a group of insurance contracts were issued to policyholders on 5 December 2024. The stocks that provide insurance cover effective from 1 Jan 2025. All right. And the first premium collection is due on 5 January 2025. Under IFRS 17, when is the group of insurance contracts initially recognized? Okay, so that's the question, right? Obviously, the answer here would be on the 1st of January, not on the 25th, on the 1st of Jan, because that's when the cover actually initially starts and there isn't any premium collection before that. And also, we assume that it's not an onerous contract. Okay, so that is the question, and we are going to ask each chatbot. Okay. Okay, let's see the first chatbot. We will let this thing run here in the meantime. Let's break it down. Insurance contracts, this effective date, first premium collection. When is it initially recognized? Okay, so here it's choosing the first premium collection. So on the 5th of January, and that is incorrect. Yeah, it's incorrect. So this method got this wrong. And then let's see what 5.4 has here. So in the scenario, there are 3, well, oopsie. So that's not a correct date over there. The key moment here would be on the 25th of December, where all parties have agreed, even though coverage doesn't start until Jan. And that is incorrect. Yeah, that is incorrect. And then let's just see what our RAG system says. Okay, so this is ready here. So it says here, according to Connor Verati's explanation in applying IFRS 17, also look at new insurance contracts 2021. So it is providing a reference there. Source. A similar example provided within this document illustrates that if an entity issues a non-onerous group of insurance contracts where coverage begins on January 1, year X, and premiums are due from premium holders starting February 5, year Y, then such groups would be recognized when they begin to provide cover. Okay, this is actually quite confusing there, but anyways, in your case scenario with the beginning date for providing protection being January 1, 2025, year X, despite premium collection commenced and in early year following this coverage start, so therefore under IFRS 17 principles as detailed by Garage, another group of insurance would be initially recognized on Jan 1 when cover provided to policyholders become effective. Okay, so it got that right. I'm not too sure about its reasoning. It got it right? Okay, so let's actually change the question now, where now the first premium collection is due on the 27th of December 2024. Now, the group of contracts should be initially recognized on the 27th of December as opposed to the 1st of Jan, right? So whichever is earlier. And of course, we assume that it's a non-onerous contract. Okay, so we try with the Gamma 3, so I suppose we would expect Gamma 3 to get it right. Because in the last example, it chose the first premium collection date as the date in which it's initially recognized. So it's probably going to assume the same type of reasoning here. So let's just see date here. The revenue must be recognized. That's the first time. Today. Does that answer the question? But initial revenue recognition is on the 27th. It just says it must be recognized in December. It doesn't really specify a date, although it's using the first premium collection. So now I'll take that as a half pass. Okay, and then the 5-4 model. And let me just run this and then we can read here. That's the 5-4 model. Deferred, related. Group is originally recorded the fair value of inception, which is 25th. So it got that one wrong. Okay, so it got this one wrong. Okay, so you can see both questions, these two models struggled. With the RAG system, the first question was okay. The reasoning was, I do not understand the reasoning. But yeah, pulled, the reference of documents. So this one is detailed here. So let's just understand. Given the facts here. Initial accounting treatment should be at inception. Given mix. Let's just see initial. Okay, so this one is wrong. Yeah, so this one is wrong. Although it's looking at, let's just see, pages 76 to 88. It's actually quite long. I'm not going to go through it, but this is quite wrong. So, as I've said, this is one of the disadvantage of RAG-based system is especially when you have a weak model, an LLM model. So I'm using the 5-4 model in terms of producing the output, and the Gamma 3 model in terms of the tool, and the nomic conveyed in terms of the retrieval, text embedding retrievals. Now it has to sort of then reason through the query and context to then provide an accurate answer. Yeah, so it failed in this case, not because it didn't sort of get the retrieved documents, but rather it was unable to actually reason through the query, reason through the question, and then reason through the context. Yeah, so this is one of the disadvantages of RAG systems, its inability to reason. So yeah, hopefully I've showed what it can do and some of the flaws of the RAG system. But then again, I'm using a very small models. It might perform better, using very large models, particularly those that are either from closed model providers. But yeah, hopefully you understand now how to build a RAG system, a knowledge-based AI agent. And yeah, so until next time.